The software utility cron is a time-based job scheduler in Unix-like computer operating systems. People who set up and maintain software environments use cron to schedule jobs to run periodically at fixed times, dates, or intervals. It typically automates system maintenance or administration, though its general-purpose nature makes it useful for things like connecting to the Internet and downloading email at regular intervals. The name cron comes from the Greek word for time, iiiy 1/2 ii chronos. Overview: cron is driven by a Crontab file, a configuration file that specifies shell commands to run periodically on a given schedule. The Crontab files are stored where the lists of jobs and other instructions to the cron daemon are kept. Users can have their own individual Crontab files, and often there is a system-wide Crontab file that only system administrators can edit. Each line of a Crontab file represents a job, and is composed of a cron expression, followed by a shell command to execute. Some cron implementations, such as in the popular 4th BSD edition written by Paul Vixie and included in many Linux distributions, add a sixth field, an account username that runs the specified job. This is allowed only in the system Crontabs, not in others, which are each assigned to a single user to configure. The sixth field is alternatively sometimes used for year instead of an account username. The NNCRON daemon for Windows does this. While normally the job is executed when the time-date specification fields all match the current time and date, there is one exception: if both day of month and day of week are restricted, then either the day of month field or the day of week field must match the current day. Examples: the following specifies that the Apache error log clears at 1 minute past midnight of every day of the month, of every day of the week, assuming that the default shell for the cron user is Bourne shell compliant. The following line runs the user Perl script test PL every 2 hours, at midnight, 2 a.m., 4 a.m., 6 a.m., 8 a.m., and so on. This example runs a shell program called export dumpsh at 8 p.m. every day. Predefined scheduling definitions: several special predefined values can be substituted into the cron expression. Note that in some uses of the cron format, there is also a seconds field at the beginning of the pattern. Command to execute: AAAAAAAAAA, AAAAA, AAAAA day of week, AAAAA month, AAAAA day of month, AAA hour, min. At reboot configures a job to run once when the daemon is started. Since cron is typically never restarted, this typically corresponds to the machine being booted. This behavior is enforced in some variations of cron, such as that provided in Debian, so that simply restarting the daemon does not rerun at reboot jobs. At reboot can be useful if there is a need to start up a server or daemon under a particular user, and the user does not have access to configure init to start the program. Cron permissions: the following two files play an important role. Cron allow: if this file exists, it must contain your username for you to use cron jobs. Cron deny: if the cron allow file does not exist but the cron deny file does exist, then, to use cron jobs, you must not be listed in the cron deny file. Note that if neither of these files exist, then, depending on site-dependent configuration parameters, either only the super user can use cron jobs, or all users can use cron jobs. Time zone handling: most cron implementations simply interpret Crontab entries in the system time zone setting that the cron daemon runs under. This can be a source of dispute if a large multi-user machine has users in several time zones, especially if the system default time zone includes the potentially confusing DST. Thus, a cron implementation may as a special case any CRONTZ equals time zone environment variable setting lines in user crontabs, interpreting subsequent Crontab entries relative to that time zone. History. Early versions. The Cron in version 7 Unix, written by Brian Kernighan, was a system service invoked from Inittab when the operating system entered multi-user mode. Its algorithm was straightforward: read etc. Crontab, determine if any commands must run at the current date and time, and if so, run them as the superuser, root. Sleep for 1 minute, repeat from step 1. This version of Cron was basic and robust, but it also consumed resources whether it found any work to do or not. In an experiment at Purdue University in the late 1970s to extend Cron's service to all 100 users on a time-shared VAX, it was found to place too much load on the system. Multi-user capability. The next version of Cron, with the release of Unix System V, was created to extend the capabilities of Cron to all users of a Unix system, not just the superuser. Though this may seem trivial today, with most Unix and Unix-like systems having powerful processors and small numbers of users, at the time it required a new approach on a 1MIPS system having roughly 100 user accounts. In the August 1977 issue of the Communications of the ACM, W. R. Franta and Kurt Milley published an article entitled An Efficient Data Structure for the Simulation Event Set, describing an event queue data structure for discrete event-driven simulation systems that demonstrated performance superior to that of commonly used simple linked list algorithms, good behavior given non-uniform time distributions, and worst-case complexity, n being the number of events in the queue. A graduate student, Robert Brown, reviewing this article, recognized the parallel between Cron and discrete event simulators, and created an implementation of the Franta-Milley Event List Manager for experimentation. Discrete event simulators run in virtual time, peeling events off the event queue as quickly as possible and advancing their notion of now to the scheduled time of the next event. Running the event simulator in real time instead of virtual time created a version of Cron that spent most of its time sleeping, waiting for the scheduled time to execute the task at the head of the event list. The following school year brought new students into the graduate program, including Keith Williamson, who joined the system staff in the computer science department. As a warm-up task, Brown asked him to flesh out the prototype Cron into a production service, and this multi-user Cron went into use at Purdue in late 1979. This version of Cron wholly replaced the Cron that was in use on the computer science department's VAX 11/780 running 32 per volt. The algorithm used by this Cron is as follows: on startup, look for a file named Crontab in the home directories of all account holders. For each Crontab file found, determine the next time in the future that each command must run. Place those commands on the Franta-Milley event list with their corresponding time and their 5-field time specifier. Enter main loop, examine the task entry at the head of the queue, compute how far in the future it must run. Sleep for that period of time. On awakening and after verifying the correct time, execute the task at the head of the queue with the privileges of the user who created it. Determine the next time in the future to run this command and place it back on the event list at that time value. Additionally, the daemon responds to SIG-up signals to rescan modified Crontab files and schedules special wake-up events on the hour and half-hour to look for modified Crontab files. Much detail is omitted here concerning the inaccuracies of computer time of day tracking, Unix alarm scheduling, explicit time of day changes, and process management, all of which account for the majority of the lines of code in this Cron. This Cron also captured the output of stdout and stder and emailed any output to the Crontab owner. The resources consumed by this Cron scale only with the amount of work it is given and do not inherently increase over time, with the exception of periodically checking for changes. Williamson completed his studies and departed the university with a Masters of Science in Computer Science and joined AT&T Bell Labs in Murray Hill, New Jersey, and took this Cron with him. At Bell Labs, he and others incorporated the Unix command into Cron, moved the Crontab files out of users' home directories and into a common host-specific spool directory, and of necessity added the Crontab command to allow users to copy their Crontabs to that spool directory. This version of Cron later appeared largely unchanged in Unix System V and in BSD and their derivatives, the Solaris operating system from Sun Microsystems, IRIX from Silicon Graphics, HPUX from Hewlett-Packard, and IBM AIX. Technically, the original license for these implementations should be with the Purdue Research Foundation, who funded the work, but this took place at a time when little concern was given to such matters. Modern versions, with the advent of the GNU project and Linux, new crons appeared. The most prevalent of these is the Vixie cron, originally coded by Paul Vixie in 1987. Version 3 of Vixie cron was released in late 1993. Version 4.1 was renamed to ISC cron and was released in January 2004. Version 3, with some minor bug fixes, is used in most distributions of Linux and BSDs. In 2007, Red Hat forked Vixie cron 4.1 to the Crony project and included Anacron 2.3 in 2009. Other popular implementations include Anacron, DCRON, and FCRON. However, Anacron is not an independent cron program. Another cron job must call it. DCRON was made by Dragonfly BSD founder Matt Dillon, and its maintainership was taken over by Jim Pryor in 2010. A web cron solution schedules recurring tasks to run on a regular basis wherever cron implementations are not available in a web hosting environment. CRON expression. A CRON expression is a string comprising 5 or 6 fields separated by white space that represents a set of times, normally as a schedule to execute some routine. Format. In some uses of the CRON format there is also a seconds field at the beginning of the pattern. In that case, the CRON expression is a string comprising 6 or 7 fields. Special characters. Support for each special character depends on specific distributions and versions of cron. Asterisk. The asterisk indicates that the cron expression matches for all values of the field. For example, using an asterisk in the 4th field indicates every month. Slashes describe increments of ranges. For example, 3-59/15 in the first field indicate the 3rd minute of the hour and every 15 minutes thereafter. The form slash is equivalent to the form first last slash. That is, an increment over the largest possible range of the field. Commas are used to separate items of a list. For example, using MON, WED, FRI in the 5th field means Mondays, Wednesdays and Fridays. Hyphens define ranges. For example, 2000 to 2010 indicates every year between 2000 and 2010 AD, inclusive. Percent signs in the command, unless escaped with backslash, are changed into new line characters, and all data after the first % are sent to the command as standard input. Non-standard characters. The following are non-standard characters and exist only in some cron implementations, such as Quartz Java Scheduler. L stands for last. When used in the day of week field, it allows you to specify constructs such as the last Friday of a given month. In the day of month field, it specifies the last day of the month. W. The W character is allowed for the day of month field. This character is used to specify the weekday nearest the given day. As an example, if you were to specify 15W as the value for the day of month field, the meaning is, the nearest weekday to the 15th of the month. So, if the 15th is a Saturday, the trigger fires on Friday the 14th. If the 15th is a Sunday, the trigger fires on Monday the 16th. If the 15th is a Tuesday, then it fires on Tuesday the 15th. However, if you specify 1W as the value for day of month, and the first is a Saturday, the trigger fires on Monday the 3rd, as it does not jump over the boundary of a month's days. The W character can be specified only when the day of month is a single day, not a range or list of days. Pound is allowed for the day of week field, and must be followed by a number between 1 and 5. It allows you to specify constructs such as the second Friday of a given month. In some implementations, used instead of asterisk for leaving either day of month or day of week blank. Other cron implementations substitute question mark with the startup time of the cron daemon, so that a would be updated to 25.8 if cron started up on 8:25 am, and would run at time every day until restarted again. See also, launched, list of Unix utilities, scheduling, Systemd incorporates Crontab, references. External links, Crontab, a schedule periodic background work and a commands and utilities reference, the single Unix registered trademark specification, issue 7 from the Open Group, GNU Cron, ISC Cron 4.1, Crony, ACM Digital Library Franta, Mali, an efficient data structure for the simulation event set, Crontab syntax tutorial, Crontab syntax explained, Unix/Linux cron tutorial, a quick tutorial for Unix-like operating systems with sample shell scripts. All about cron on one page, a page covering cron, starting with theory and ending with many practical examples about its usage. Dylan's Cron expression translator, small site that tries to convert a Crontab expression to English, Cron sandbox, Cron simulator, try out Crontab timing values in a sandbox. Put in the cron time date values and get back a list of future runtimes. Crontab syntax generator, choose date time, enter command, output path and email address to generate a Crontab syntax.